Hi, everyone. I'm Güneş Kesik. I'm working as Research and Innovation Engagement Manager at Ericsson Research since 2021. Ericsson is the global project coordinator of ROBUST-6G project, and I'm taking care of the project coordination on behalf of Ericsson for ROBUST-6G project. In this presentation, I will briefly present the ROBUST-6G project idea, our consortium, the project objectives, our work packages in general, and the ROBUST-6G demonstrators finally. We have already seen some details about the project budgets and the durations, but let me share the the long name of our project to show the main aim of our project. ROBUST-6G is aiming to generate smart, automated, and reliable security service platform for 6G. The overall budget of our project is around 4.2 million, and the expected EU contribution is around 4 million euro. And as I said, I'm the project coordinator. In this project, instead of having single technical coordinator, we have a technical management committee. We will be closely working with Molusanka Lianage, Stefano Tomasin, and Manuel Gil Perez for the technical coordination of ROBUST-6G project. When we look at our consortium, we have 13 partners from 7 different countries. Geographically, we have a well distribution. And from the academic and industry partners distribution perspective, we also have a very well-balanced consortium. We have 3 SMEs in ROBUST-6G project, 3 large enterprises, 6 universities, and 1 research institute. And the 8 of our partners are 6G II members already. When it comes to the project scope, in order to address the demanding needs of 6G use cases, 6G networks must be highly programmable, flexible, and adaptable. However, in order to provide this programmability, flexibility, and efficiency, we will have to cover or we will have to address this complexity in monitoring and or managing the 6G networks. To bring this complexity under control, we need a paradigm shift towards end-to-end automation of networks and services. However, we see a significant obstacle to achieve this aim, because in order to provide full end-to-end security, we have to secure the network services and infrastructure and data from potential cybersecurity risks. And ROBUST-6G is aiming to address these cybersecurity risks by introducing cutting-edge approaches for security management of 6G networks at the level of services, infrastructure, and physical layer. In order to do this, ROBUST-6G will be providing fundamental contribution to data-driven AI/ML-based security solutions. Moreover, we will be working on the security and robustness of distributed intelligence, privacy enhancements, and transparency by elaborating explainable AI methodologies. Of course, when we consider AI tools or AI agents, sustainability of these tools is very important. So that's why we are planning to implement some green AI methodologies to optimize the computation requirements to automate this security and network security operations. ROBUST-6G will also generate a fully automated end-to-end smart network and service security management framework by utilizing zero-touch network and service management approach and AI/ML techniques. And lastly, ROBUST-6G is planning to provide advanced AI/ML-based physical layer security solutions and increase the trustworthiness and resilience of 6G radio, also considering the new radio technologies like distributed MIMO, reconfigurable intelligent services, and providing novel physical layer security techniques for these technologies. When we look at the project objectives, we have 7 objectives. The first objective is the analysis of anticipated 6G architecture and scenarios and identification and characterization of threat landscape in an AI-driven 6G network based on globally connected heterogeneous environments. And objective 2 is providing an end-to-end 6G security architecture with inherent AI functionalities that will seamlessly integrate different functions in a heterogeneous network environment and enabling 6G scenarios with high security requirements. And objective 3 is propose methodologies or develop methodologies to ensure AI-driven security functionalities are robust, sustainable in terms of energy efficiency, explainable, effective in terms of performance, and privacy preserving in all aspects. And the fourth objective is mostly related to zero-touch automation of these security functions and the resources to be used in these security operations for trusted and certified services among multi-stakeholder, multi-tenant, distributed dynamic scenarios. Objective 5 is more related to physical layer security. And in order to ensure trustworthiness and resilience at lower layers of 6G network, we are proposing AI/ML-enabled smart techniques to detect and mitigate physical layer attacks on network and user devices. And we are planning to propose novel physical layer security schemes for demanding scenarios when we consider the low latency, low energy consumption, and low complexity expectations from different use cases. And taking into account, as I said before, new radio technologies like DMIMO. And in the 6th objective, we will showcase and validate our innovations, ROBUST-6G innovations, through proof of concept studies, through predefined use case scenarios. And the last objective is to carry out extensive dissemination, communication, and exploitation activities to increase the overall impact of our project. The work package structure, we have 7 work packages. I will not go into details, but because I will show with the key innovations related to these work packages later on. But the first work package is dedicated to project management, the last work package dedicated to dissemination and exploitation activities, and we have 5 technical work packages. I will come later to work packages in the upcoming slides. When we look at
1 minute, you have 1 minute left.
Okay. I will go very quick then. The ROBUST-6G architecture, when we consider the this high-level architecture, we have some verticals here. These are the consumers of the network, and they have different expectations and different quality of service demands from the network. These services or these consumers will be reached to these network services through these unified exposure framework APIs. And when we look at the details of the architecture, we have a data management module, which is an output of work package 2. And this data management module will be responsible from the whole data flow of the security operations. And we will also be developing an AI/ML-driven security architecture for 6G network as an output of work package 2. And for work package 3, we will be developing mainly distributed AI-driven security module, which will be responsible from trustworthy, sustainable AI-driven security functions and distributed federated learning services. And it will be also responsible from AI lifecycle management. And you can see the innovations related to this work package as well. And in work package 4, we will be handling zero-touch security management module, and the AI models generated in work package 3 and distributed AI-driven security module will be implemented here in the agents, and these agents will be responsible from the zero-touch automation of the security functions. And we have here security administration console, which helps or enables human intervention if it is necessary, and it will provide explanations regarding the actions taken by these agents in an explainable by using explainable AI methodologies. And lastly, we have physical layer security module, which will be utilizing AI/ML fingerprint-driven detection of physical layer attacks for trustworthy 6G radio, privacy and sensing integrity, and anomaly detection for 6G physical layer finger printing, and enhancing trustworthiness and resilience of 6G radio with physical layer security. When it comes to demonstrators, we have 3 demonstrators. In the first use case, we will be evaluating the trustworthiness of AI models we develop within this project through the trustworthiness evaluation framework, which is an output of our work package 2. And we will be using zero-touch automation of threat detection and mitigation, especially in 6G-enabled IoT environments. And lastly, we will showcase network security as a service approach that we are going to develop in this project through this third use case. And thank you, and sorry for not using the time very efficiently.
No problem, Güneş. You stayed nearly exactly on the 10 minutes.
Okay.